Okay, let's talk about exponential and log forms of an equation. So if we look at 2 cubed equals 8, this is known as an exponential equation, right? It has an exponent in it. It's a true equation, all right? It is true that 2 cubed is 8. Okay, so this is exponential form, okay, or just an exponential equation. Now, if we compare it to what we see over here, log base 2 of 8 equals 3. Okay, that's how we would say that in words. Write that down if you need to. Log base 2 of 8 equals 3. So notice that this whole log is equal to 3. So a log, we say, is an exponent. Alright, so next time you're hanging out on a Friday night and a buddy says, hey, you know what? What the heck is a log after all? You could say, you know what? A log is simply an exponent. And then your friend will have the answer to his or her question, and life will be good. So look right here. The exponent is 3. So a log is an exponent, right? It's equal to an exponent. So the base we say is 2. So right here is the base in the exponential equation. Down here, that's where we put the base in the log equation. Okay? So we tend to summarize this using the phrase ben. So written in exponential form, some base raised to some exponent will equal some number. Over here in log form, we see the log of some base, and then what we tend to do is we draw this cycle of arrows to kind of show you the sequence here. So this base, log base b, if we were to raise it up to the exponent, we would have some number, okay? So log base b of n equals e. Alright, so same thing up here, 2 raised up to the third would equal 8. Okay. Now something such as log base 4 of 2 equals 16. This would not make sense. This would not be a true statement because, again, if we were to do our ben here, okay, this 4 raised up to the 16, that is not equal to 2. Alright, instead, this should be log base 4 of 16 equals 2 because 4 squared is 16. So we want to make sure that when we are writing an exponential equation in log form, you want to make sure that what you're writing is actually true. Okay? So again, it's the idea of whatever you have here in the bottom, right, in the basement, all right, you have to then raise it up to something, and then that will give you that number. Okay? Okay, here's an example where we wish to evaluate, which means find the value of log base 5 of 125. So let's suppose we're not allowed to use a calculator. So we're trying to figure out what this is equal to. So one thing that you can do is you can just set it equal to x. X represents what it's equal to. So from there, what you want to do is take it out of log form and put it into exponential form. So we want to write an equivalent equation, but just change the form. Okay? So you have 5 raised to the x equals 125. Okay? So from there, hopefully you know that 125 is 5 cubed. Okay? So we have the same base, so x would be 3. You don't have to show that step. If you know it's going to be 3, you could just write it down. So the final answer would just be 3. We don't really want to write x equals 3. We put that x in there as like a placeholder. Okay, so the value would be 3. Okay, and by the way, sometimes you can go the opposite direction if you want. All right, I've been putting the equal sign on the right-hand side, but you could put it on the left-hand side and go this direction. Okay, so it's the same idea. You would still have the same exponential equation. Okay, so you can go in either direction. Just make sure you end up with that same exponential equation. All right, let's look at another one here. Suppose we wish to evaluate log base 64 of 4. So again, you might want to consider setting it equal to x. All right, you can set it equal to whatever you want. Okay, you could use a question mark, you can use an empty box. It's totally up to you. So from there, we know that 64 raised up to whatever this whole log equation is equal to needs to equal 4. So recall that we always want to try to get a common base if possible. So this 64, that is 4 cubed. Okay, and then we have 4, which is really 4 to the first. So we are successful here in getting a common base of 4. So from there, we can ignore our bases and just set our powers equal to one another. So our answer would be 1/3. Okay? So in other words, 64 raised to the 1/3 is equal to 4, right? A 1/3 power is the same as a cube root. So if you just knew that by looking at this original expression, that's fine. Okay, you don't have to show the work if you don't need to. Okay. Okay, we're going to look at some special cases here. The first one is where we have log base 5 of 5, or in general, log base A of A, so those values match. So we're trying to figure out what is this equal to. Okay, sure, you can set it equal to x, or you can just use your brain and think about what it's going to be. So we know whatever we put in this box has to be the exponent. So 5 raised up to what will give us 5? Well, it must be 1, right? Because 5 raised to the first is 5. So that suggests that log base A of A is equal to 1. So that's our first special case. Okay, here's our next one. So we're looking at log base 2 of 1, and then in general, log base A of 1. So again, just use your brain and think about this. 2 raised to what must give us 1? Well, 2 raised to the 0 power. Recall a 0 exponent will give you 1 for your result. So anytime we have a log of 1, doesn't matter what the base is, you're going to get 0. Well, I should be careful. Your A value has to be greater than 0. Okay. If it's not, it'll be undefined, as we'll see here in a moment. So suppose we wish to find the value of log base 3 of 0, or in general, log base A of 0. So we're trying to figure out, okay, 3 raised up to what will give me 0? Well, it's tempting to think the answer would be 0, but recall that 3 to the 0 would give us 1, not 0. So you can think all day long. The bottom line is you're not going to come up with an answer. That's because this is undefined. Okay? So again, if you were to set this equal to x, 3 to the x, when is this equal to 0? Recall what your graph looks like. It's going to look like this, and we said how it's never going to hit 0. So that's why it's undefined. Alright, so in general, this is undefined. Okay? Cannot log 0. Okay, another special case here. We're trying to figure out log base 3 of something, which we can call that x. That all needs to equal negative 27. So 3 raised to the x equals negative 27. It's tempting to think the answer is negative 3, but it's not. If you were to do 3 to the negative 3, that's 1 over 3 to the positive 3, which is 1 over 27. Okay, so this equation has no solutions. Okay, so that suggests that you cannot take the log of a negative number. Okay, so this also is undefined. So in general, log base A of B is going to be undefined if B is less than or equal to 0. Okay, so you cannot log a negative number, and you cannot log 0, as we saw in the previous one. And finally here, suppose we wish to take the log base a of a to the n. Okay, so I'm talking about, sorry, I kind of wrote this backwards here, log base 3 of 3 to the 4th. Okay, we're trying to figure out what this is equal to. So if we were to think about using our Ben here to rewrite this in exponential form, we'd have 3 to the x equals 3 to the 4th. Well, notice how you have the same base, so this whole thing would just equal whatever that power is. So this is suggesting that if the bases are the same, the base of the log and the base of this exponent, if they are the same, then the whole expression for this log is just going to be that power. So again, here you see these are the same. This whole thing is just going to equal n. Okay?